The moment has finally arrived for this scrappy little Ford Ranger to stop embarrassing itself and start making some actual horsepower. Picture this, 12 years ago, I pulled a 351 Windsor from a Bronco's cold, greasy heart and rebuilt it in a storage unit. Yeah, a storage unit. The birthplace of big dreams and questionable decisions. On a budget tighter than a drum, I bored the block, cleaned it up, and slapped on mostly stock Ford parts. Back then, cramming a 300 horsepower V8 into a Ranger was pretty rad. Fast forward to 2025, and 300 horsepower is about as impressive as angry eyes on your Jeep. The Ranger has seen its fair share of upgrades over the years, but now, it's time for the heart of the beast to get its glow up. In this episode, I'm throwing a pile of go-fast parts at this trusty 351 Windsor and turning it into a fire-breathing 408 stroker. Buckle up, because things are about to get a little bit reckless. So the crank that we're putting in is a forged 408 stroker crank. This is what's going to make more power. The connecting rods are probably going to hit on the piston holes, some of that skirt material in there, and we're going to have to take care of that. So we're going to drop the crank in and see where we have clearance issues. And obviously there's nothing for it to really hit here, but right around here is where it can get squirrely. Now, I don't have a piston, so I could really move this thing. And you're supposed to have 0.063 clearance between this and everything else is what I'm seeing. If you're following this for a step-by-step guidance, you're in the wrong place. But this right here does not appear to have any clearance issues that would require me to open it up at all. Ample clearance in there. I can dang near fit like a finger in there almost. Maybe not quite that much, but anyway, I'm going to move it over to the next one and then we'll try this side. So right here, this is where the oil pump mounts on the Ford. When you go just enough right there, obviously I'm moving it, but that's hitting right there. And with it centered in the bore, it's pretty dang close. Obviously, again, I don't have a piston on it, but we're going to clearance that just a little bit. The last thing an engine block wants inside of it is thousands of pieces of little metal. So I got this device here that turns nodular iron into thousands of pieces of little metal, and we're going to grind on this block and try to keep as much out of it as possible. I got it prepped for surgery. Luckily, we don't need very much. Oil pump pad, it's about to get a little bit thinner. After the engine block was clearanced for the new crankshaft, I ran a cylinder hone through all the bores to deglaze them and just prep for assembly. This is just a cheap cylinder hone from Amazon and some motor oil from lubrication. Pretty simple process, just go slow. And this is one of those where less is a little bit more instances. You don't want to take too much out of the cylinder with this. The main thing I learned rebuilding this engine inside a storage unit, a pressure washer and a can of spray paint is some of the best turd polish around. And this is a perfect example of that. For this build, I opted to do a custom grind camshaft spec'd exactly for my purposes and build. Really, it was like $20 or $30 more than just a regular off-the-shelf camshaft, and it should work really nice with how I'm going to be using the truck and how it's going to be built. This is the part of building an engine that is tedious and a little bit time consuming, because it takes a while to file fit all 16 of these rings and assemble the pistons. Make sure you read the instructions with your piston rings, as manufacturers do things a little bit differently. I'm using Wiseco forged pistons. These have valve reliefs cut specifically for the twisted wedge cylinder head that I'll be installing in a little bit here. And it has a disc shape to put the compression ratio right near 10:1 for this build. The upper and lower rings are beveled differently, and usually there's a dot or a marking to indicate which side goes up. This ring in particular, it has an N on one side to indicate the top of the ring. And I use this cheap piston ring filer to set all the ring gaps. It's a slow process. You file and check fitment, file and check fitment. I count revolutions when I'm doing this, so I have an idea of how much each ring will need to be filed. Again, follow the manufacturer's instructions for the ring gaps. It will vary by material properties and thickness. I set these ring gaps for a moderate street performance use, and it should work nicely. Roller lifters are a crucial upgrade for modernizing this small block engine. Since this is a 1989 block that wasn't originally designed for roller lifters, I'm using link bar roller conversion lifters from Howard's Cams. It's a simple, effective way to bring this old engine into a more modern era. Factory forged cylinder heads? Complete dumpster fire. It's like Ford went out of their way to design something that would smother horsepower in its sleep. This build is going to get an upgrade with some trick flow twisted wedge 11R heads. These pack a 205cc intake port and 66cc combustion chamber. This engine's finally going to get to breathe for once. I had to keep the compression ratio in check. I don't want the engine throwing a temper tantrum because I can't find 93 octane fuel at some backwoods gas station. You know, this truck is built for adventure, not a gourmet fuel diet. I use a Sharpie to color in the top of the valve stem and then just reassemble with the rocker arm on there, and I will run it through 4 times and then check a wear pattern on that little Sharpie mark. Alright, so I tried a couple different lengths, and I got it on the third try, I got it to where the wear pattern is going right in the middle of the valve. And if it's too high, you extend your push rod. If it's too low, you make your push rod shorter. So I started on the high end and worked my way back. Got it right here in the middle of the valve stem where it's supposed to be. And if anything, it's better to have it a little bit higher up than too low, but I'm right here in the middle. So I'm gonna record my measurement and then do the same for the exhaust valve. I'm gonna try the same length, but hopefully it's the same. If not, you know, we'll have to adjust it again. But it's not unheard, you know, it's possible that you have two different lengths, one for intake, one for exhaust. To wrap this thing up, I'm going to talk about some of the parts I threw on here at the end to wrap up the engine. Ford Racing valve covers, these are the tall versions. I had to buy the tall version to clear those rocker arms I installed. My stock height would not fit over them. Holley fuel rail system, this came with the intake, and I have 42-pound Holley injectors. That obviously I still need to get fuel connections and sort that stuff out, but that will be once the motor's in the truck. These are some Flowtech small block forward headers, 1 3/4 inch primaries. I am going to modify these in a later video. I plan to cut this flange off, both of them, add a V-band, and I'm probably going to have to change the angle a little bit on these to get it to squeeze between the Ranger frame. Not a big deal, but I'm going to have to do a whole exhaust anyway, so that'll be fun. This is just a part store water pump, nothing special about it. ATI Super Dampener, this is a neutral balance because the crank is balanced, so the dampener is neutral. Holley dual sync distributor, so you have to get this distributor to be able to clear the high ram, but this also gives me a ton more capability and options with tuning compared to just the regular distributor with the Ford TFI module. So I wanted to do this anyway, just to have options when tuning this to get the most power and performance out of it. So this will be messed with a lot in a later video. I need to get a thermostat housing, but I want to get the accessories on there and look at where the radiator output is to figure out the best way to do that. Oil filter relocator. This is from Canton Racing, the same as the oil pan. This is billet aluminum, and it is very nice, way better than the setup I had before. And I like that I needed to get one that pointed forward, because before this, still the relocator pointed directly at the engine cross member. So this will be much nicer to work with. It is a nice piece, and yeah, happy to have that. Otherwise, that's about it. Oh, there's one other thing. I acquired a full nitrous kit.
I had some parts for sale on the marketplace and someone offered me a trade. I accepted it because they've been sitting there for a while, and now I have a nitrous kit that I don't know what to do with. But I have a Terminator system that can run this nitrous very well. The engine internals are all forged and can easily handle any amount of nitrous that I want to throw at it. The rings are gapped properly if I wanted to add nitrous. Obviously not an extreme amount, but I don't know. What do you guys think? Is this totally stupid to add this in there? It wouldn't be like a right away thing. It would be, you know, down the road once I get it running and driving good without it. But I don't know. I'm kind of half tempted when I build out the interior to just throw this bottle in there somewhere and make sure I can hook it up easily. So what do you guys think? Drop in the comments. Should I add nitrous? Yes or no? That's gonna be it for this episode. I got a lot of work ahead of me, and this is the year. This thing is getting done. I'm gonna be hyper focused on this project. I have a nice big new badass motor to install in there. I'm motivated to get this thing done. I want to be doing 4-wheel drive burnouts, and hopefully I don't throw a rod through the roof of the shop or something like that when I go to fire this thing up. Thanks for hanging out in the shop and watching the episode, and until next time, stay reckless.